Good evening. My name is Natalie Bailey. I'm a third professional year pharmacy student at the College of Pharmacy and Pharmaceutical Sciences at the Florida A&M University. Today I'll be presenting my journal club, and my topic is the comparison of effects of the different dexmedetomidine and chlorohydrate doses used in sedation on electroencephalography in the pediatric population. This article was first published on September 22nd, 2014. It was later published in the Journal of Child Neurology in July 2015. The population for this trial was 160 pediatric patients, of which 85 were boys and 75 were girls. The trial designs were a single-blinded, randomized test. Patients were randomly divided into four groups: D1, D2, C1, and C2. The D group received dexmedetomidine, and the C group received chlorohydrate. The arm of this trial were: in group D1, there were 42 pediatric patients, and they received a 2 microgram per kilogram dose of dexmedetomidine. In group D2, there were also 42 patients, and they received 3 microgram per kilogram of the drug. In group C1, there were 30 pediatric patients, and they were given 50 milligram per kilogram of chlorohydrate. In group C2, there were 40 patients, and they received 100 milligram per kilogram of the chlorohydrate. This trial was done in Turkey, and it was approved by the local ethics committee of the local ethics committee, of the University of USA. The inclusion criteria for this trial were children ages 1 to 9 who were uncooperative during an EEG recording. The exclusion criteria includes children ages 1 to 9 who were allergic or had an hypersensitivity reaction to the drugs chlorohydrate and dexmedetomidine. Also, other exclusion criteria were children who had systemic diseases such as cardiac disease, respiratory disease, neurological diseases, metabolic, and gastrointestinal diseases. The subjects of this trial were children ages 1 to 9 and who were uncooperative during an electroencephalography procedure. The endpoints of this trial revealed that chlorohydrate was rapidly absorbed from the gastrointestinal tract. Its sedative and hypnotic effects occurred within 20 to 60 minutes and lasted 60 to 120 minutes, while dexmedetomidine had a rapid distribution phase and a half-life of 6 minutes. The secondary endpoint were, after the procedure, out of the four groups, D1, D2, C1, and C2, the overall adverse drug effects based on the dosage that were given to each group showed that group D1 had a 2.4% adverse effect, group D2 had an 11.1%, group C1 had a 15%, and group C2 had a 25% of adverse effect. The p-value here was 0.004. The follow-ups for these trials were conducted at the hospital, and after the hospital stay, there were no way of finding out if there were any adverse effects of both drugs that were given. The duration of the trial was only 24 hours. Statistical analysis. The mean induction time was found and were as follows. For group 1, there was a 35.9 induction time. For group D2, there was a 34.5 induction time. For group C1, there was a 34.0 induction time. For group C2, there was a 28.9 induction time. The induction time was significantly shorter in group C2 compared with other groups. The mean EEG recording time was 37.7 plus or minus 6 minutes, with no significant difference amongst the group. Mean recovery time was 41.7 for group D1, 48.3 minutes for group D2, 52.2 minutes for group C1, and 70 minutes for group C2. The recovery time was significantly longer for patients in group C2. The mean total sedation time was as follows. Group D1 had a total sedation time of 109 minutes, while group D2 had a total sedation time of 114.6 minutes. Group C1 had a total sedation time of 117.8 minutes, while group C2 had a total sedation time of 130.3 minutes. The total sedation time was significantly longer again for groups C2 compared with other groups. The overall sedation failure rate was 16.7% in group D1, 7.1% in groups D2, 22.2% in groups C1, and 5% in groups C2. There was no statistical significance difference in sedation rate failure amongst the group. The results of the trial. The indication of EEG recordings were suspected in the children that were in the trial. So some were suspected of having epilepsy. Some were suspected of having seizures. And in the group 1, the reason for the referral for the EEGs were they were suspected of having epilepsy. Adverse effects. After the procedures, hypoxia developed in one patient, which was a 22.8% in group C1, and one patient, 2.5% in group C2. Both patients were treated and supplemented oxygen were supplied to them with no airway management. After the procedure, children were noted to have more agitation in group C2, 2 patients. Children are also noted to have hypertension. This was developed in one child in group D1. Bradycardia occurred in one patient in group D2. Vomiting and nausea developed in 3 patients, which accounts for 8.3% in groups C1, and 7 patients in groups C2, which accounts for 17.5%. The limitations of these trials were this study had a small sample size of only 160 pediatric patients, but that is understandable because Not a lot of people will, give their child up for trials or studies because it has negative connotation to let your child go in and do some trials or studies. So one of the limitation was the population size. Another limitation was the short follow-up period. The children were only followed during their hospital stay, which was a 24-hour stay. They weren't followed after they leave the hospital to see how the reaction of these drugs carry on, because they were eliminated by renally, and so but when they left the hospital, they still had some drug in their system. Other limitations were that the sample size in each group were not evenly distributed. The D groups had more children in their sample size. The author's conclusion of this trial: it appears that the oral dexmedetomidine is a safe and effective drug for sleep during an EEG recording in the pediatric population. The authors also observed that the dexmedetomidine was effective at a dose of 2 micrograms per kilogram in 83.3%, whereas dose of 3 micrograms per kilogram were effective in 92.9% of the patients, respectively. Furthermore, there was no significant difference in adverse effects between the two doses of dexmedetomidine. On the other hand, the authors found that 77.8% of children were sedated effectively with 50 milligrams of chloral hydrate, whereas 95% of the children were sedated effectively with 100 milligrams of chloral hydrate, respectively. The adverse effect of chloral hydrate were more commonly seen in the patient, whereas who were sedated with 100 milligrams. In addition, total sedation time was significantly longer compared to the groups receiving dexmedetomidine. So the total sedation time with the chloral hydrate was longer. And with the pediatric population, once their procedure is over, it is always safer for them to be aroused shortly after. It is not good to have the child sleep beyond a certain period of time. And as this trial is turning out, it seems as if the chloral hydrate had a longer sedation time, longer time for the child to be aroused. The strength of this trial, one of the strengths of this trial is that it is a comparison trial. It is comparing two drugs. The trial was not funded by the group that was carrying out the study. It was not funded by, it wasn't a biased trial. It compares the efficacy, again, of two drugs used to sedate the pediatric population. And as I said, there's not a lot of pediatric trials that we have. And so any trial we can have, and the parents that volunteer their children to go through these trials are well appreciated. Also, the researchers used different doses of both drugs. So they didn't just use one dose of the drugs that were in the trial. They used different doses to compare the efficacy and the safety. The weakness of this trial is that it had a small sample size again. Also, the age range could have been larger. The age range for the children that were in this trial were only from ages 1 to 9. The summary of primary literature. According to this trial, the researchers confirmed that, considering the adverse effect and long sedative time, chloral hydrate 3 milligrams per kilogram of dexmedetomidine seemed to be an appropriate sedative option for EEG recordings in children. Again, 3 milligrams per kilogram of dexmedetomidine based on this trial were favorable to the researchers. In order to use dexmedetomidine, one should achieve a proper indication with peace of mind in children for sleep, according to the authors. I have concluded from this study that this article provided that dexmedetomidine has a better efficacy in sedating the pediatric population than chloral hydrate. In my opinion, further studies with larger sample size and longer follow-up period, as well as different doses of dexmedetomidine and chloral hydrate, are needed. However, until such studies are conducted, I would highly recommend the use of dexmedetomidine, and the brand name is Precedex, over chloral hydrate for sedation in children for EEG, because it has fewer adverse effects. And also, it interests me, this drug, because it was used on my child not too long ago, and the outcomes were favorable. My reference for this study was from jcn.sagepub.com. Thank you for your time and your convenience.